Hello everyone, I will show you how to complete assignment 2 from the DSP or data science principle, and the assignment title is create the Azure machine learning workspace. So in this lab we're going to explore creating the Azure machine learning workspace and also use it to train the model using the auto machine learning or auto ML. So earlier during the flip class, I have already explained what is the Azure Machine Learning Workspace. Yeah, it's basically a place in the cloud in Azure, which contains the resources like the CPU, processor, compute, yeah, then memory, and the storage, and also the other infrastructure such as notebook, and then the pipeline, and including the AutoML, which we can use to do the training the machine learning model and then create the machine learning model. Yeah, okay. So this is the first lab to use the Azure Machine Learning Workspace. So we focus on familiarizing you with the environment, and at the same time we use one of the nice features in the Azure Machine Learning Workspace, which is the Auto ML. Okay, because the process will take time, so without delay, we create first. Yeah. So I already have logged on with my trainer account, and you should log on with your Lytton student account, and just to make sure that you check the subscription. You have the subscription of the Azure Student Labs. Yeah. So mine is yeah, the same. Yeah, Azure Student Lab. Yeah, this is my subscription, same as yours. Yeah. And then here in the home, yeah, then after that I have the resource group name Azure Labs faculty RG. Yeah, your resource group should be something like this. Yeah, so the name should be the PDDS, and then the 0925 TAA and Azure Labs group. Yeah, this is your resource group for a student. Yeah, you will be able to see the resources that you create and also your classmate, but you can only manage your own resource group. Yeah, your own resources in the resource group. So the resource group is shared among the group. Yeah. Okay, so let's start. Yeah. So here we're going to create the resource, and just to make sure that you choose the correct Azure Machine Learning. Yeah, Azure Machine Learning. You type the Azure Machine Learning. Okay, here you go. Yeah. Okay, then after that, choose this the icon. Yeah, you see on the right there, this one, and then choose the correct subscription, Azure Student Lab. Yeah, if you have already activated the free trial account, don't use that. Yeah, but use this Azure Student Labs. This is free for you to use and created pre-created for you to use. Yeah? And then the plan is Azure Machine Learning. Yeah? Click create, and then you need to provide the information. Subscription, make sure you choose Azure Student Lab, and then resource group, choose the existing one. Don't create a new one. Yeah, don't create. Yeah, so you should use the existing one. If you create a new one, yours, then it might fail. Yeah, because the policy does not allow you to create the resource group. So only use the existing one. The name, yeah. So here, follow this template. Yeah, your name, and then after that, creation date. Yeah, then after that, I change this with Ryan. Yeah, and then 2025 11 27. Yeah, like this. Okay. Yeah. So this is the, and you can choose East US. You can leave it, or you can choose Southeast Asia. Yeah, in the Asia, and then Southeast Asia. Can we find Southeast Asia? Okay. And then source account, it will be given the name automatically based on our machine learning workspace name. Just leave it default. Yeah. Okay. And then after that, only letters and numbers. Okay. So all good. Yeah. The region, you choose the region. Resource group, choose the one that pre-created. Default, not the default. Yeah. Default. Yeah. Okay. So nothing, yeah, just click review and create to validate the options. Okay, so validation passed, then you can continue by click the create. Okay, so this process will take a while, and in the meantime, you can see the bell. You see there is a one notification, yeah, that currently is submitting the deployment of this Azure Machine Learning workspace. Okay, so we leave it running. Okay, yeah, just wait for a while, and this will be deployed and ready for us to use. Okay, while waiting, we're going to download the template, yeah, and then after that, we're going to create a sample screenshot. Yeah. Okay. Yep. So this is the template, and then I'm going to copy to create a sample. Okay, everyone, this is the template. Yeah, you're going to create the screenshot. Yeah, machine learning workspace resources in resource group created, and then the Machine Learning Studio launching page, and then Auto ML job configuration screenshot, and then a job page after the job submission. Okay, this is for sample. Okay, so let me say first, then we will come back again to put the screenshot here. Okay, yeah, so completed. Yeah, Azure Machine Learning workspace created. Yeah, your deployment is completed. This is the first screenshot. Yeah, created machine learning workspace and resources in the resource group. Okay, so go to the resource. Okay, so this one is the Azure Machine Learning workspace. Yeah, okay. So click, and then after that, create this screenshot. Okay, here you go. Okay, yes, okay, here. Then Machine Learning Studio launching page. Okay, launching page ML. Okay, here you go. Yeah, Machine Learning Studio launching page. Okay, so we can screenshot this. Launch Studio. Okay, that's the second screenshot. Okay, then after that, this one is the AutoML. Yeah. Okay, let's continue. So click the Launch Studio. Okay, after that, so in here you have the notebook sample. Yeah, then there are many things. Yeah, web classification. Yeah, GenAI with prompt flow. But on the left we have this. Yeah, notebooks automated ML. So we're going to learn to use this, but not everything will be covered in this lab. Yeah, so just look through this what available here. Yeah, and then we focus on the auto ML later. Yeah, the automated machine learning. Okay, so we have the authoring notebook, automated ML, asset, and so on. Yeah, so we're going to learn one by one later. Yeah, not in this module, not in this assignment, but in the next view assignment. So part 2 already done. Yeah, we already collect the screenshot. Then now we continue with the part 3. Yeah, train the model using the AutoML. Yeah, AutoML is automated, so it is useful, but not much thing we can learn from AutoML because many things are automated. Yeah, we only do the AutoML lab 1 or 2 times. Then the rest we don't use. Yeah, because we want to learn more. We want to be able to optimize to understand how the training the model in the Azure machine learning workspace. Yeah, with AutoML, not much we learn. Just click, finish. Yeah, then we get the result. Yeah. Okay, so for these purposes, you need to download the training data. Okay, you click this. Yeah. So you can copy the link, and then after that, copy. After that, download. Okay, this diabetes data. Yeah. Okay, so here this is diabetes zip. Then I will extract here. Extract here. Yeah. So now we have the diabetes data. So refresh. Where is the data set? One. The name is diabetes.csv. Okay. So diabetes.csv. This one, yeah. Okay. Diabetes.csv. Okay. So now we have this, yeah. Diabetes.csv. Maybe I'm going to yeah, that's right. Yeah, we're going to upload later. Okay, then click the AutoML, follow the here this lab, yeah, and then click a plus to create a new AutoML job. Okay, and then in the base setting, you give unique name for training the job and experiment. Use the default. Okay, so the name is Ryan. Yeah, after that the assignment 1, assignment 2. Sorry, Ryan assignment 2. Yeah. Okay. If the name is already used, then you need to put the unique identifier like 1, 2, 3 or the month and date of today. Yeah. Okay, so maybe I just put 2, 2025, 11, 27. Okay, and then after that, yeah. So basic setting, automatic. Yep. Okay. So new experiment, you choose the default, yeah, or you can also yeah, this one I copy this, yeah. Okay, Ryan assignment 2, yeah. Then this is the job name, yeah. Okay. After that, yeah, task type in data. Okay, you put the description, yeah, assignment 2, diabetes classification. This is up to you. You can leave it blank, yeah. Tag value, yeah. Next, after that, the task type is a classification. Classification, remember, yeah, you want to predict yes or no, true or false, yeah. We call that the 2-class classification or binary classification. You can also create a multi-class classification like a green, yellow, red, yeah, multiple, more than 2. This is the diabetes, yeah. So diabetes is basically classification. We want to predict the label whether diabetes or not, yeah. Okay. So after that, select the data, and then after that, create data set, yeah. Okay. And then in the data type, give a name your data set, which is training data. Okay, then select next, yeah. Okay, you choose the type machine learning table, yeah. Okay, next, yeah. After that, from the local file, and then from local file, you upload, yeah. Okay, yeah. Select from local file to upload the training data that you download previously, yeah. Select next, yeah. Okay, so in the destination storage type, yeah, Verify Azure Blob Storage is selected as the data source type. Yeah, this one. And then the workspace blob storage is the data store selected. Yeah, select next. Okay. And then now we're going to upload. Yeah. In the ML table selection step, select the upload folder. Okay. Then select the folder you extracted from the compressed file downloaded earlier. Yeah, which is under the download. Yeah. So we have the diabetes. Yeah. Okay, diabetes. .csv. Okay, where are? Okay, download folder. Sorry, this is folder, yeah, folder. Then after that, the upload. Oh, no, no, no. Where are? So we're going to select the correct one. Downloads. After that, the yeah. So we're going to choose the file only. Folder download. Yeah. Okay. Upload. This will upload for all files. No, cancel. Yeah. So choose a folder to upload from your local drive with the ML table tab. You must upload a single folder that contains a well-defined ML table file at the root, yeah, along with the reference data file. Okay. Yeah. So I think I have to this one. Yeah. So diabetes. So I create the diabetes data. Right click. Then after that the extract. Yeah. To diabetes data. Okay, so this is a folder. So upload the folder. After that, inside the this one, yeah, this folder. Upload. Okay. Yep. So this is the diabetes data.csv. Upload it. Yeah. Okay. Then after that, review the setting, and then after that, create. Yeah. Okay. Then after that, yes. Like upload folder. Select the folder you extracted from. Yeah. Next. Review the setting. Yeah. Back. Okay. Then after that, next. You may need to select the classification task type again before moving to the next step. Okay, let's see. You click the create. Yeah. Okay, so click create. Data type, training, description, data source, folder selection. Okay. Yeah. So create. This is to create a data set. Okay. Yeah. Success. Yeah. Okay. This is the training data. Okay. Then finish. Yeah. Classification already. Then after that, already, yeah, training data already created. Yeah, you select, then after that, in the task setting, select the diabetic boolean as your target column. Yeah, okay, diabetic boolean. This one. Yeah. So this is the label, the column that we would like to predict in the classification, diabetic or no. Yeah, the boolean. Yeah, yes or no. So boolean meaning yes or no. You want to create a model that predict whether someone is a diabetes or not. Okay, open the few additional configuration setting option. This one, yeah. In the additional configuration pane, change the primary metric to accuracy. So we have a few things here selectable, but we would like to focus on the accuracy. What is accuracy? Yeah, later we're going to discuss when we learn about the confusion metrics in the classification result. Yeah, okay. So at this moment, just accept this first. Okay, yeah. Then save. No need to change anything. Explain the base model and use the all supported model. And then expand the limits. Yeah, here. Expand. Then after that, you're going if you don't set the limit, yeah, it will take a very long time, yeah, because the AutoML will compare different model with the different metrics, yeah. So you can limit, yeah, that it will only try maximum trial 10 times, yeah, and then the timeout is 60 minutes, yeah. If 60 minutes not finished, then it will stop, yeah. Then iteration timeout is 15 minutes per oh sorry, no, maximum trial is 10, yeah, okay. So after that, experiment timeout. Okay, here you go. 60 minutes. And then iteration timeout is 15 minutes per iteration. If longer than this, then it will stop. Enable early termination check. Yeah. So what is the purpose is if the best model is achieved, found, yeah, discovered before the 60 minutes, yeah, then it will stop earlier. Yeah, it will not wait until finish. Sometimes the machine learning found the best model already, yeah, less than the maximum time, then yeah, it will stop. Yeah, it will not wait until finish. Okay, for the test data, select the train split. Okay, test data, yeah, train split, train test split. Verify the percentage test is data is 10%. Yeah, okay, 10%. So training is 90%, and the testing is 10%. Like this, yeah. This is 90%. This is 10%. Okay, after that, select next. Okay, so how you going to run? Yeah, you're going to use the and the virtual machines serverless and standard DS3 version 2. Okay, so DS3 version. Okay, I think this one. Yeah. D2, D3 version 2. Actually, you don't need to change also can, yeah, no problem. Anyway, we don't pay, yeah. A number of instances, one is enough, yeah. Okay. Then after that, next. In the large, if the data is big and then you will consume resources, you can add the more compute instance, yeah. Can add more than one, yeah, or you create a compute cluster. Okay, so back to this, we have the screenshot to take, yeah. AutoML job configuration screenshot. Okay, this is the job configuration before we submit, yeah. Okay, we take the screenshot. Okay, so this is the AutoML. Okay, here you go. Yep. Then after that, job page after AutoML job submission. Okay, yeah. So after that, we just click then yeah, next, yeah. Then submit the training job. Okay. So this will take a while until this finish, yeah. Okay. We going to wait for a while and after submitting the job, you will be redirected to the jobs page. Jobs allow you to keep track of the workload you ran and compare them with each other. And jobs belong to experiment, which allow you to group the job runs together. Okay. So there is no detailed explanation about what expected from this, yeah. But we're going to wait a while. Then I will add additional information about the expected result from the AutoML. Okay, just wait for a while. Yeah. Okay, so I just resume again the recording and I have a pause for a few minutes. Yeah, and then this is the result or temporary still in progress. The model is still training. Okay, yeah, so we have not completed yet, and just still waiting. Yeah, and in the meantime, when you click the job here, yeah, then after that you can see the list of the job, and the job might broken into the multiple sub job. Yeah, so this one is all jobs. Okay, yeah, so if you expand, you can see that actually there are parallel jobs that running. Yeah, okay, and then this is the status. Yeah, okay, this is name randomly. Okay, so currently is still in a running status. So I just wait for a while again. Yeah, leave it running. Okay, so click. Yeah, then after that come back here. Model training. Yeah. Okay. This one. Now we have the message. Yeah. So the job is completed. Yeah. Okay. Then after that we would like to refresh. You see the status completed. Yeah. Okay. So the AutoML successfully completed our job, and then choose the best model. Yeah, which is this Azure ML. Which one? Yeah, this one. And then you click the best model. Okay. Yeah. So here already finished. Yeah, job. Okay, maybe we look at the last screenshot first. Yeah, job page after AutoML job submission. Okay, and then this one is already completed. Yeah, okay. So jobs where in the jobs. Yeah, here. Okay, here you go. This one. Yeah, already completed. So we take the screenshot. Okay, then after that here. Yep, here you go. So I can close this. But we have not finished because I'm going to explain a bit about this result. For the submission is enough. Yeah. But let's see here. In this one, yeah. This is the best model that selected by the machine learning. The model. Yeah. Okay. Here. Yep. So one moment. Beta. Then go back here. Jobs. Yeah. All jobs. Okay. 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 Yeah. This is the one. Okay, artifacts. Yeah, click the artifacts. So the artifacts, this is the AutoML automatically create the machine learning model. Then after that, the requirements and so on, the configuration. Yeah. Then it has a jobs itself. Yeah. Then after that, the data. Yeah. After that, the feature set. Not much thing created here. Yeah. But what this one is a log model. Okay. We're going to look at the one. Yeah. Okay, so this is showing the result. Yeah, input, output. Yeah, then after that here the matrix. Yeah, so just now we compare the model based on the accuracy. So the best accuracy is 95%. Yeah, and then we have the other metrics which we can find here. Okay, yeah. So the precision, and then after that the accuracy and so on. So what is accuracy, then you will learn that separately, yeah, in the Wikipedia. After that, the confusion metric. Okay, here we go, yeah. So we have the accuracy and then the precision and so on. So we have this definition, yeah. Like for example, accuracy. Yeah? Accuracy is basically the true positive plus the true negative divided by the positive and negative, or the total. Yeah. So we going to learn separately about this. Yeah. True positive and then false positive, and yeah, yes, we will cover that in the classifications module. But just now we look into the best model with the highest accuracy, which is found here. Okay, so you can find under the view all other metrics. Okay, yeah, this one. Okay, so you can see this one, yeah, the table. Okay, and then after that here the accuracy table is close to 1. Yeah, close to 1 meaning 100%. Meaning that every time in 100 times prediction, then 95% is correct. Yeah? That's the meaning of the accuracy, 95. Yeah. Okay, this is the ROC curve, which is showing you the square, yeah, 1 to 1. Yeah, if the model perform the perfect prediction, it will give you the 1, which is always true. Yeah, but this one sometimes give the wrong prediction. This is the naive prediction, which is just yes or no, just like guessing, yeah, which is 0.5. And this is your model. Yeah, it's quite good. Yeah, and this is the distribution. So when the prediction is correct, yeah, and this is the naive predictions without the model. Okay. So this curve we're going to learn separately, yeah, but I just show you in the very quick way. I remember someone, I think Hanbun, yeah, so mentioned about after completing the AutoML, then don't know, yeah, don't understand, yeah, what because we have not actually learned. This assignment is more into familiarizing you with the Azure Machine Learning Workspace and AutoML, but we have not learned to discuss the result of this experiment, yeah, creating the model classification with the AutoML. Okay, just be patient, then we come to that part in understanding this. Maybe I just shortly explain to you, yeah, the meaning of the true positive, yeah, is basically when the machine learning model predict true and then the actual is true, yeah, that's true positive. And true negative is when the machine learning model predict as no and then the actual is no, yeah. And then the false positive is when the machine learning to predict as yes but actually no, and the false negative is machine learning predict as no but actually yes, yeah. So of course the best model is when the true positive and the true negative is the highest, yeah. Okay, yeah, so that's the additional explanation about the classification which was created in this AutoML. Okay. Okay, so I stop and we're going to learn more, yeah, in the following labs or modules.